So this is the first Unit 5 factoring video, and it will cover how to factor out a greatest common factor. Okay, so any expression, whether it's quadratic or whether it has larger exponents than just 2, they might have a greatest common factor that we need to factor out. And so that's what this video is about. So to start, I want to make sure that we understand this concept of factoring. So let's write a real basic definition to start with. To factor something is to kind of undo some multiplication. It's like going backwards. Okay, so we're breaking down an expression into its factors. So let's write that down. Factoring is breaking down an expression into its factors. Okay, and sometimes it'll break down into 2 factors, sometimes it'll even break down into more, but we'll get to that later. And this is kind of like undoing multiplication, I had said. So that's one way to think about it. We're undoing multiplication. Okay, so let's look at this first example. I want to start with a multiplication problem that would be really familiar to you and show you how when we undo that, that's called factoring. Okay, so for our first example, if I gave you 4 parentheses 5x minus 2, okay, and you were asked to multiply. Well, we have a single multiplier on the outside. That's called a monomial, just a single term. And we have 2 pieces, 2 terms inside the parentheses. It's called a binomial. And so we know to multiply, we use the distributive property, and we multiply that 4 into the binomial, right? So we end up with 20x minus 8. And that would be our answer. Okay, so kind of the reverse of that, okay, so to factor, that would be like me giving you, to start with, 20x minus 8. And when I ask you to factor, we're undoing that multiplication. So we're looking for that multiplier, that common multiplier. Okay, that's the greatest common factor that you see in both 20 and in 8, right? So 4 goes into both of those. It's the largest number that divides into both 20 and 8. Okay, we have 4 times 5, and we have 4 times 2. And that 4, that is that greatest common factor. So you pull that back out, right? It's kind of like dividing it out. That's our greatest common factor multiplier. And then you put back into parentheses what was left in that expression. So we like divide out that 4. So 20x, divide out the 4, we're left with 5x. And the negative 8, we divide out the 4, we're left with a minus 2. Okay? So see how with our answers, what we started with on the multiply side is what we then ended with on the factoring side. Okay, so they just kind of switched spots here. And so this is the answer to the factored form, and this 4, that is what we call the GCF, the greatest common factor. And so we had to divide that out and pull that out of each term. And so this is our final answer. This is how you'd write it. We have broken the expression down into its parts, or into its factors. One of those is the 4, and one of those is the 5x minus 2. Okay, let's look at another example. Okay, so for example 2, if you were asked to, first we'll do the multiply version, okay? And if I gave you 3x and then in parentheses 2x plus 1. Okay, well, this is our single multiplier. We would multiply it into the parentheses using the distributive property, right? And the 3 times 2 is 6. But now we don't want to forget there's an x in each term, and x times x is x squared. Okay, so we need to remember we change the exponent. We add those exponents together. So we've got 6x squared, and then 3x times 1 is positive 3x. Okay, so that is the answer when we multiply. So now, remember when we factor, it's like going the opposite direction. Okay, we're undoing the multiplication. So if we start with 6x squared plus 3x, and you're asked to factor, you're looking again for that common number and potentially a variable, an x, that go into both pieces. Okay, so notice here the 6 is 3 times 2, and the 3 is 3 times 1. We know that 3 goes into both. And then the x's, right, x squared means x times x. And this x, well, we just have one of them. So they have one x in common. Okay, so we take that common piece, the 3 and the x together, and then we put back into parentheses, we divide out that 3x, and we put back into parentheses what's left over. So the first term, the 6x squared, when you divide out the 3, you're left with a 2, and when you divide out an x, you're just left with that 1 left over, right, because there was 2 total. And then the second term, we took out both the 3 and we divided out the x, and so we're just left with 1, right? 3x divided by itself is just 1. And so this would be our answer of factored form of that original expression. Okay, we divided out the greatest common factor. All right, for example 3, let's start with the expression that we want to factor. It is negative 4x squared plus 6x plus 10. Okay, and we want to look through each term. Notice we have 3 terms now. Okay, 1, 2, 3, and we need to find the largest factor that is in each of them, right? Like what has been multiplied into each, what do they have in common? You might immediately say a 2, right? A 2 divides into all of those. But another thing that's true of this is this negative is something of interest, okay? When the term here with the largest exponent, that x squared, when it is negative, I want my greatest common factor that I divide out to also be negative. Okay, so when I find that GCF, and then I put back into the parentheses what was left over, I want that to be negative. Okay, so in this case, when we say that, oh, there's also a 2 that goes into each of those terms, we're actually going to divide out a negative 2. Okay, so what that means is that inside the parentheses, I need to have what's left of those original 3 terms after dividing out the negative 2. So in the first spot, we have the negative 4, we divide out the negative 2, and we're left with just 2, right? Because negative 2 times 2 is the negative 4. And then we also have the x squared still there, right? We weren't able to take out any x's because there wasn't an x in this third term here at the end. In the middle, we divide out a negative 2, and 6 divided by negative 2 is negative 3, right? And then we have the x remaining. So notice how when we take out a negative, it changes the sign of that term. And at the end, the 10 divide out negative 2, we're left with negative 5. Okay? And that would be our answer. Okay, it's negative 2, parentheses 2x squared minus 3x minus 5. And notice, if we were to take that negative 2 and multiply it back through the parentheses, we would get exactly this original expression. And that's what we want. Okay? And then also, the reason that I had us take out a negative here as part of the GCF is because we want this first term inside the parentheses to be positive. That's going to help us later on when we do some more factoring. And so if there's a negative out front of the first term, the one that has that largest exponent, we're going to make sure to take out that negative as part of the GCF, and then we'll have a positive in that first term in the parentheses. Okay, and again, that's what we want. Let's look at a few more examples for you to work through on your own. So go ahead and write down examples 4 and 5 and factor out the greatest common factor. So remember, the final answer always has the multiplier back out front and then in parentheses what's left over, right? You're like dividing out the GCF and putting in parentheses what's left over from each term. So I'll go ahead and pause the video and then I'll show you the answers in a few minutes. Okay, here are the answers to these two examples. Okay, you'll notice in example 4, in each term, the 9 and the 12, they both have a greatest common factor of a 3, right? So I made sure to pull 3 out. And then I also look at the variables that go with them, and they both have x's, okay? And so really here, as I look at the exponents, the first term has 3 x's, and the second term, well, if it's not written, it's x to the first power. So I need to make sure to take all of that lowest x exponent, okay? So I can take out a single x, and so I did that here. I brought out the 3x, that's like x to the first power. And so I'm left with these 2 x's in the first term, but notice no x's in the second term, okay? I can't leave any common factors in this parenthesis piece, right? In number 5, notice this is one with that negative out front. Okay, so notice that I brought a negative out as part of my greatest common factor. That is something that I want you to do. Okay, and then notice, some of you might have just brought out a 5 as part of your greatest common factor, but notice there is something larger. Okay, 15 goes into each of these numbers in each term, and so that's the largest number that they all have in common. Okay, and so we do want to take out the greatest common factor. And then I also notice that they each have an x. If each term doesn't have this x term, okay, notice this has 3 x's, the middle term has 2, and then there's 1 in the last term. If they don't each have an x, you wouldn't bring an x out front. But because they do, and this 1 here, that's the smallest exponent, you bring out that 1, right? It's like x to the first. And so notice that what's left over in the parentheses is just then 1 less than what they started with. X squared in the first term, just an x to the first in the middle term, and then no more x's in the last term. In fact, notice in the last term, the entire term, the 15x, was the greatest common factor, so we're just left with a 1. Another thing to note, because of that negative that we pulled out front, notice what happened to each term inside the parentheses. It's really just the opposite sign of what it started, right? The first term was negative, but now it's positive. The middle term was negative, now it's positive. The last term was positive, now it's negative. So pulling a negative out as part of the GCF, all it does is it flips the sign of each term inside the parentheses. Okay, so those are some strategies for factoring out the greatest common factor.